This is my worked problem number 3 for the thermo-charrette number 2. So we have a problem. Consider a simple ideal Brayton cycle operating between the temperature limits of 300 and 1500 Kelvin. Using constant specific heats at room temperature, determine the pressure ratio for which the compressor and the turbine exit temperatures of air are equal. So we can write down our givens right off the bat. We know that T1 equals 300 Kelvin. We know that the maximum temperature, T3, equals 1500 Kelvin. And we know that our specific heat ratio, is going to be 1.4. Now, we can first start off by looking at the isentropic compression from states 1 to 2. And we know that we can use the equation T2 over T1 equals P2 over P1 raised to K minus 1 all over K. We know that P2 over P1 equals our pressure ratio. So we can substitute our P2 over P1 to our pressure ratio. Start getting in terms of our pressure ratio. So T2 over T1 is going to equal RP raised to K minus 1 all over K. And you can multiply T1 over, and T2 equals T1 times the pressure ratio raised to K minus K1 all over K. Now we already have it. We have our first term in terms of T2 to figure out when the compressor and turbine exit temperatures of air are equal. Now we have to get in terms of T4, and we can start analyzing from states 3 to 4, during which is an isentropic expansion. And we know that during this, T4 over T3 equals P4 over P3 raised to K minus 1 all over K. Now, like before, we want to substitute out P4 over P3. However, we need to remember that while P2 over P1 is equal to the pressure ratio, P3 over P4 is the one that's equal to the pressure ratio, not P4 over P3. So then, instead of substituting out straight for the pressure ratio, we have to substitute 1 over the pressure ratio to get our correct answer. And then I'm going to multiply T3 over, and we get T4 equals T3 times 1 over the pressure ratio raised to K minus 1 all over K. Now we have our expressions for T2 and T4, and we want to find what the pressure ratio is when the compressor and turbine exit temperatures of air are equal. So when T2 equals T4, we can pull down our expressions, and we can set T1 times the pressure ratio raised to K1, K minus 1 over K equals T3 times 1 over the pressure ratio raised to K minus 1 all over K. Now we're going to rearrange our equations a bit to get T3 over T1 equals the pressure ratio raised to 2 times K minus 1 all over K. And then we can invert the whole expression, so we get the pressure ratio is equal to T3 over T1 raised to K divided by 2 times K minus 1. Now we have our equation. properly, we can substitute in our values, and we know that T3 is going to be 1500 Kelvin all over T1, which is going to be 300 Kelvin, raised to the pressure, the specific the specific heat ratio of 1.4 divided by 2 times 1.4 minus 1. When we calculate that all out, we get the pressure ratio when the compressor and turbine exit temperatures of air are equal is equal to 16.718.